All right, in today's lesson, we are going to start off by talking about functions, and more specifically, how they increase and decrease and how to identify them. All right, well, first off, a function is increasing if between any 2 points on the interval, a positive change in x, okay, results in a positive change in f of x. If you're looking at a graph, f of x, that's the same as y, isn't it? And what does that mean? If I have, okay, a set of axes here, I have a grid, as x increases, y will also increase. So what does that mean? As I go this way on the x, I increase. I go this way on the y. So it kind of goes up like that. That is an increasing function. We can look at that as this function has a positive slope. All right? Now, likewise, a function is decreasing if between any 2 points, a positive change in x, that means we're slowly going to the right on the graph, results in a negative change in f of x. And let's not forget, that's the same y. So in my graph here, okay, here's my x and here's my y. As I move to the right on x, okay, that positive change in x, I get a negative change in y. So as I move to the right, I'm kind of going down, all right? That is a decreasing function. It has negative slope, all right? And last but not least, a function is considered constant if between any 2 points on the interval, a positive change in x, we're still moving to the right side of an x, results in no change in f of x, which we also know as y. All right? So what does that look like? That tells us if on our graph here, all right, we still have x and we still have y. As I move to the right on the x, as x increases, y does not move up or down. That kind of just maintains. Okay? So as I move this way, there you go. Y does not move up. No. It does not move down. No. It stays the course. That is a constant function. That also means it would have a slope of 0. Remember, any horizontal line has a slope of 0. And as a quick review, what about, okay, this is what the line looks this way. What if a line is graphed and goes up and down straight? That has no slope. It has an undefined slope. It's a vertical line. I don't know, that's really not in the notes here, but I just wanted to hit that up quick for review. So on our next slide, we have a couple of examples, all right? The graph on the left, is that an increasing constant or a decreasing function? Well, you got to read these graphs like you would read a book, like you're reading a sentence from left to right. So as I go from left to right, increasing on the x-axis, my y is also moving in an upward direction. That means this would be an increasing function. All right? Now let's take a look at the graph on the right. I'm still going to read this left to right. I'm going to start on the left and go to the right. And you can see my right is moving downward, this graph. So as I move and increase my x value, my y value decreases, okay? So therefore, the function is decreasing. It's really that, just plain and simple, okay? Well, let's take a look at the next two graphs. Okay, let's take a look at the next two graphs. This one, actually, as I move to the right, has no change. It doesn't go up or down. That's the one we call a constant. Oh, last but not least, what is this one? Well, as I move left to right, I move left, and it's kind of going down here, isn't it? That would denote decreasing, wouldn't it? That would be a decreasing function. But once I get to this point, and I move to the right, that looks like there's no change. That looks like it's constant. And then from this point, it looks like it's increasing. So what do we say about this function? We We say it decreases, it's constant, and it's increasing. If they happen to want to know what interval, you can say that it decreases, okay, it decreases, right, from negative infinity, all right, this is an arrow here, it goes this way, it goes to negative infinity on the x, all the way to an x is 0, negative infinity to 0, all right? What about when it's constant? It's constant from when x is 0 to when x is 2. So from 0 to 2, it's constant. And last but not least, and this should have an arrowhead here, it is increasing from when x is 2 all the way to positive infinity. So from 2 to positive infinity. Now, notice that all these intervals here, these aren't coordinates, they are x values, my intervals. Okay, they're all x. This is an x value, and so is this. They are not coordinates. That is the interval from negative infinity to 0 on the x-axis. Okay, this one right here is the interval from 0 to 2. This interval here is from 2 to infinity. All right, positive infinity. All right. So we can actually describe not only its decreasing constant and then increasing, we can describe where that happens. Okay. Boundedness. Boundedness. It sounds a lot like boundaries. And for any of us that play sports, whether it be soccer, football, tennis, basketball, anything that's kind of in an arena where there are out of bounds, we know that the boundaries just denote that exactly. That's where there's a line where you can't cross or play stops. Okay? So, when I look at this first graph and I think, okay, how is this bounded? Because we're going to describe this graph on the left here. This one right here. We're going to describe this graph. How is that bounded? Well, that is bounded below. Why do I say that? This goes up forever. There is no boundary here. That goes up forever. Here is the absolute low point, okay? It doesn't go any further below than that little imaginary line that I just drew there in red. So there's a boundary below, isn't there? So that's why we call this graph bounded below. All right, likewise, if I look at my second graph here, I look and it goes down forever. There is no boundary below. This goes down forever. It doesn't stop going down. It's all good. But at some point, it stops going upward, right around here. Okay? It stops going upward. Therefore, there is a boundary above. Not below, because it goes down forever, but it stops moving up right around this point. It doesn't get any higher. That's our boundary above. So we say it is bounded above. All right? Now, this third graph right here. Well, there's a boundary above. It doesn't go any higher than this. There's a boundary below. It doesn't go any lower than this. Well, you can say Visca, it goes left and right forever. And that's fine, because my boundaries, they only, when we describe boundaries and bounded, it only affects the ups and the downs. I don't care about lefts and rights. So this is bounded both above and it is bounded below. We don't say it's bounded above and below. We just say that it is bounded, period. If I say something is bounded, that means it is bounded both above and below. If I only want to say that it is bounded above or bounded below, that's when I say bounded above. Or I would say bounded below. But for moving on, from this point forward, if I just say bounded, that means it is both above and below. All right? And last but not least, this one goes up forever and it goes down forever. Again, I don't care about this. I don't care about the left and right when I'm talking about boundaries. All right? It goes up forever and down forever. It is not bounded above or it is not bounded below. So we just say it's not bounded, period. I think that's pretty simple. All right, mins and maxes. Mins and maxes. These are relatively easy to see on graphs, okay? We have two different types of mins and maxes, okay? We have our local, which they sometimes call relative minimums and maxes. And then we have absolute mins and absolute maxes, okay? So what do we talk about when we talk about local mins and maxes? That would represent all of our peaks and all of our valleys and our mountain ranges. And I'll explain that as we move forward. In fact, let me tell you that right now. Peaks are all your high points, and valleys are all of our low points, okay? Now, what about absolute mins and maxes? That is the tallest peak, or the highest of high points, and the lowest of low points, or our lowest valley. So, if I look at this graph right here, it goes down forever, doesn't it? But look, this is a high point. That is a peak. That is a max. That's a maximum right there, okay? Let's look at our next graph. This one has a high point here. That's a max. And we have a low point here. That's a minimum, all right? Now, we can consider these absolute because since it's the only one, it's the highest one, isn't it? This is an absolute minimum because it's the only low point we have. Same thing here. On the graph on the left, we can consider this an absolute maximum because it's the only point, so therefore it is the highest one. There's one thing I want to point out here. This point here, the coordinate is 1, 2, 3, 4. That coordinate right there is at 0, 4. Okay? So they may ask you, when it comes to the maximum, they can say, where is the maximum? That happens at x equals 0. They may ask you, what is the maximum? The maximum is 4. That's the y value. Okay? So the what would be the y, and the where is the x. Where does this occur? When x is 0. What is the height? The height is 4. All right? It's a very basic piece of information I wanted to share along with you. That's important to know. Because they can ask you where is the maximum, or they can ask you what is the maximum. And that is basically the where is your x, what is the maximum, that's your y. All right, let's take another look here. Okay, let's identify all the maximums. We have a maximum here, because that is a peak. It's a mountaintop. We have a maximum here, and we have a maximum here. These are all maximums. Here, here, and here. If I had to guess which one the absolute maximum was, it would be this one, because this is the tallest maximum. Okay? These are all local or relative. Relative max, relative max. All right? Now let's take a look at our minimum. It looks like there's two valleys here, or low points, here and here. Okay? These are our minimums. Here and here. This is the absolute minimum. This is the absolute lowest point. And this one could be a relative or a local minimum. All right? Pretty simple and straightforward. Let's look at our next graph. Okay, where are the minimums? Well, obviously this is a minimum. That's an absolute minimum because that is a low point. And you also have another valley or low point there. That's a relative minimum. All right? Are there any maximums? Yes, there are. Right here. That is actually a maximum. That's a little mountaintop. It goes like this, comes down like that. That's a mountaintop right there. And since that's our only, well, you know what? No. This is a relative max. How come that's a relative max? That's not the highest point, is it? This thing goes up forever. This thing goes up forever. There are other points that are taller than that. So I would call that a relative mass. So that's it. All right, have a good one.